Well, hello Internet, and welcome to my NumPy tutorial. In this one video, we're going to review the vast majority of the NumPy library using numerous examples. And if you don't know, NumPy is an absolutely amazing scientific computing library that's used by numerous other Python data science libraries, which I will review in upcoming videos. And it contains many mathematical arrays, string functions, and so many functions, and they're very, very useful to do things like work with linear algebra, statistics, simulation, data science and machine learning, and so much more. And I have a lot to do, so let's get into it. Okay, so I'm going to be using Anaconda, and I have a link in the description on how to install this if you want to use the same thing I'm using. Specifically, I'm going to be using the Jupyter Notebook, and to open it up, you just click on Launch. And I went and created a file inside here, very simple. And you can see all the different things that I'm going to be covering in this tutorial. So a whole bunch of different things. What I'm going to do first, however, is I'm going to import NumPy as NP, so I can just keep that nice and short. I'm not going to do a lot of plotting in this tutorial, but I will do a little bit of it because there's so much to cover with NumPy that I want to focus on it. But I will play around with some plotting a little bit, and that's what that library is for. I'm also going to import a random function, and you're going to be able to get all this code. There's going to be a link in the description. All right, so the first thing I'm going to do is I'm going to create a regular Python list. So let's just call it list1, and I'm just going to throw some random values inside of it here. Now, if I wanted to create a NumPy one-dimensional, meaning one-axis array object, I could come in and let's just call this NP array just so you can tell the difference. I could just come in and go NP array and take that list that I created. There's numerous different ways to do this. I could also define the data type here if I would like. So let's say that I wanted this to be a byte. I could do so, and this is going to accommodate the values 1 through 5, so that's perfectly fine. I could then come in, and if we wanted to display what I just put together here, just type in our new array name and hit Control and return, and you can see there it is. I could also create a multi-dimensional list, and I'm going to do it in the same way, even though this is not the way that I normally create multi-dimensional lists. I'm going to do it this way just to show you. So in this situation, I'm going to create our multi-dimensional list, and you can see that I'm just breaking everything apart into brackets like that. See, there's multiple different brackets. And then we can say 4, 5, and 6, and 7, 8, and 9. Okay, so there's a multi-dimensional list. Now I'm going to turn it into a NumPy array. NumPy, and let's just call this M array1 is equal to, and again, you're just going to go call our array function and pass our list inside of it. All right, so let's start working with some of these guys. Give us a little bit more space. You're also going to be able to create arrays by defining start values, stop values, as well as step. So let's say that I wanted to come in here and create a range of values from 1 up to 10. And you can see I generated all those right there. And I could also come in and do a step. So let's change that to 2, and there you can see it stepped up through those, and of course I can change those to whatever I'd like. I'm also going to be able to go and generate floats, again with a defined start and end, and then a number of values. So let's say I go NP lin space, and let's go from 0 up to 5, 7 values, and there you can see those are generated for us. And you can also see here, if I change this from 7 to 5, how they change each time that I work with them, depending upon how many values I'm looking for. And I'll show you more examples. We're also going to be able to generate arrays that are just filled up with zeros. So let's just go NP and zeros and 4. And you can see, generated those guys for us. I could also generate a multi-dimensional array that is filled up with zeros, again, in much the same way. So zeros. And then inside of it, like if I wanted this to have 2 rows and 3 columns, I would throw a tuple inside of here, like this. And you can see it generated that for us. I'm also going to be able to fill arrays with 1s. So let's just change this from zeros to 1s. And there you can see that changed. If I wanted to get the number of items that I have inside of an array, I just call size. You see that works out to 9. And of course, I can go and generate arrays using default values. So let's just call this NP array2 is equal to NP and array. And then you just create your multi-dimensional array inside of here. You can also get the data type for your arrays. So let's get 2 just by calling dtype on that array. You can see these are integers, 64-bit integers. And you can see here is a list of numerous different types. You can use booleans, characters, shorts, integers, longs, floats, doubles, and you can see ranges of values depending upon which of the data types that you choose to use. So this is a big one, and that's what we're using whenever we go and create an array with a default data type. If you wanted to generate random arrays, just go MP and random. Just make sure you import this guy right here, that random library. And I'm going to generate random ints. So random int. And let's say I go 10 to 50 and 5. You can see it generated all those. Again, it's going to work in much the same way to generate random matrices. So let's say I wanted to have a 2x3 array instead of 5. I can just come in and change this to size is equal to and assign a tuple. So let's make it 2x3. And there you can see, generated it, and they are random. Another thing that's going to be useful is very often you'll want to know specifics about a function that you're working with. You can just type in, like let's say we wanted to find out more about the random function or random int function. Just type in function name with a question mark, control enter, and you can see it's going to open up and give you a ton of information about what all the different parameters are for it and examples and so much more. So there's a quick intro into arrays, and now I want to talk about slicing and indexes. Now you're going to be able to change values at specific indexes, so let's just go and get MP multidimensional array 1, and let's say we want to change the upper left-hand corner value. You can do it this way, and let's say we want to change that to 2. You're also going to be able to do it in a slightly different way. You could also come in here like that and go item set, and let's change a different one just so you can see things are different. So change this to 1 and assign a value of 1 to it. You can then come in and MP array, and there you can see change the first value to 2 and change this one to 1 right there. Let's get rid of those changes though, keep everything the way that it was. You're also going to be able to get to the shape or overall size of arrays just by ending this with shape. And there you can see. And that's just a tuple that you can get individual values from it, just like you do with any other tuple. You're also going to be able to get values by index. So let's say that I would like to get the top row and second column. And you can see that's set for 1. You're also going to be able to get the same thing by going item and then throwing a tuple to this. So instead, change this from brackets to parentheses. There, I did actually execute it. It's a different, here, I'll do this just to make sure. Okay, there you go. You could also get specific indices. So let's say we go NP and take and the array that we're working with, and then pass inside of brackets 0, 3, and 6. You can see that comes back as 2, 4, and 7. Why don't I go and print this guy out here just so you can see what it looks like. And you're going to be able to use print inside of here just like you do anywhere else. So I'll go like this, maybe do a new line, and then there we are. And now you'll be able to see all the different parts and how I'm pulling that data out. We're also going to be able to replace provided index values with new values just by using put. So we can go put, throw in our array we're working with, and get our index values here. So we'll go 0, 3, and 6. And our new values that we're going to throw inside of there, let's throw 10 inside of there just so they really stand out. And then show the new array. And you can see how we changed those. And if you're wondering how this works out, this would be 0, 1, 2, this one right here, 3, 4, 5, 6. So we're changing this column worth of data, 2, 4, and 7, as you can see right there. You're also going to be able to slice up these arrays. So let's say, let's go and throw this inside of here. NP array, let's use the one-dimensional. And let's say that I would want to get the starting of the array by leaving it blank. That's what that's going to do. So leaving this area right here with nothing, that's going to start at the beginning. And I'm going to go through the fifth, and then I'm going to take 2 steps. And you can see how we were able to pull those values out. You're also going to be able to come in with like a multi-dimensional array. And let's say we wanted to get the second value from each row. Just come in and do a colon with a comma and a 1. And there you got it. And you can also flip arrays. So let's go and get this guy right here again. And to flip it, all you need to do is go colon, colon, and -1. And it flips it. You can do things like, let's say that we wanted to get even values. Let's go and define evens is equal to NP M array 1. And just define our condition here. So we'll go like this, and 1. And we will do modulus 2 and see if that is equal to 0. Just make sure you use square brackets here, no parentheses. Okay, so now that we've defined our conditions, we can just say evens, and you can see it grabbed only the even values out of there. So pretty neat stuff. You can do this with so many conditions. Here, I'll show you a couple more conditions. Let's say I wanted to get values from that array that are greater than 5. I could come in. Let's just go and get that array, and just go get the array once again and say greater than 5. There we are. We're also going to be able to use logical operators. So let's say I wanted to get values that are greater than 5 and less than 9. I just define the conditions inside of the brackets, inside of parentheses whenever I'm using multiple. So I'll say I want to define that array, and I said greater than 5. And just a single and, go get the array again, and I said less than 9, and there you go, got those as well. We can also use an or like this, and let's say I wanted to get values greater than 5 or values equal to 10. Greater than 5 or values equal to 10, and I got them. And the final thing here is I'm going to show you so much more, but finally, if you wanted to get only unique values from it, throw that in there with unique, and you get all the unique values. All right, so there you go, whole bunch of stuff. Now I want to talk about reshaping arrays. Okay, so let's say we go and we get our multi-dimensional list, and we want to reshape it into a 9-item single axis array. That's how you do it with reshape. And then we can also come in and resize it to say 2 by 5. You're also going to be able to resize just by taking that array and then defining you want it to be a 2 by 5 array instead. You're also going to be able to transpose the axes. So let's take this and let's just say transpose, and there we are. Going to be able to swap axes. Let's just keep this going just by saying swap axes, and we'll say 0 and 1 because that's all we got. Whoops, forgot to put the dot inside of there. There we are. You can also flatten the array just by calling flatten. There it is. Another thing we can do is we could flatten in different orders. So let's say we wanted to flatten in column order. Just go like this with an F. There we are. We would also be able to sort rows. So let's go in and sort them just by calling sort. And we will sort with axis 1. And there they're sorted. And also we would be able to come in and sort the columns just by changing this from axis 1 to axis 2. And there you can see the changes. All right, so good stuff. And up next, I'm going to talk about stacking and splitting arrays. All right, another thing I'd like to do here is I'm going to generate some random arrays. So I'm going to call this SSAR1, and I'm going to call our random int function, and I will say 10, and I want my size to be 2 by 2. Okay, so I got that set up. So just copy this and print this out so you can see. And you can also see it's random. And you can see that values will go from 0 up to but not include 10. That's what this guy's for. Let's go and create another one on top of that. And let's just call this 2, because we're going to be stacking and splitting away. And let's go and print out this information so that you'll be able to see the arrays and how they are changing. So just throw this inside of here and our array, and then grab this and throw this down here, and then change this to a 2 and this to a 2. There we are. And now as we change things, we'll be able to see how the arrays are being changed. So what I want to do here first is I want to stack array 2 under array 1. To do that, you just go and call vstack and then list whatever array you want on top. So if you want your array 1 on top, well, that's what you put on top. And then if you want array 2 on the bottom, well, that's what you put on the bottom. And there you can see how they worked that out. Could also stack horizontally. So we can come in and just change this to hstack and then leave everything else the same. And there they are, horizontally stacked. Let's say you'd like to delete the second row on each of your different arrays. Let's go and store this in a new array. So I'll call that 3. You just call delete, and then the row that you want to, or the array you want to work with. And then if you want to get rid of the second row, well, that would be 1 because it's 0 indexed. And let's go and do the same thing for our second array here also. Let's go and store this in 4 and change this to 2 and run it. And you can see how we deleted those. We're also going to be able to combine arrays. So let's get rid of this part right here. And there's a bunch of different ways of doing things. Like there's a concatenate function. I'm not going to bother showing you that, but just, there's so many functions. And they all do the same thing. So this is just combining the arrays. So I'm going to call column stack, and I'm going to use the third and the fourth one that we just created. And you can see those stacked up. You can also stack in a 2-dimensional array, just with row stack instead of column stack. So change that to row stack, and there they are. And also you could come in here and do even crazier stuff. So let's go and create another array here. Call this 5, and it's just going to generate a random one as well. So let's just go and copy this as well. So here's our random array, and let's change this to 10 instead. So we'll have 2 rows and 10 columns. And the reason I have that set up, and let's go and print this out also just so you can see how it changes. All right. And then let's go and split it into 5 arrays, taking from both the arrays in our multi-dimensional array. And this is done with horizontal split. And then I just pass in the array that I want to work with and 5. And there you can see the original and how I went and broke those pieces up into 5 different arrays instead of just one big giant one. And you can even do things like, let's say I wanted to split after the second and the fourth column. So let's keep this like this. And then let's just change this to a tuple, second and fourth. And you can see how they broke those up. So second, fourth, and then all the rest. All right, so a whole bunch of different ways that we can stack and split arrays. And now I want to talk about a bunch of different ways we can copy. Okay, so let's just call this copy array, just to keep my naming conventions the same. They sort of make sense for the tutorial. They might not make sense for the real world. Let's go and create a random array here. So there we are. And 2 by 2 and values from 0 to 9. Seems pretty good. All right, so what we want to do here is if you would go and create another array like this, and you made it equal to the first one that you created, just know that both of these variables are going to be pointing at exactly the same array. So if I would come in and go CP array 1, get the upper left hand corner, and I would make that into 2, and I come in here and say that I want to change or output both of these just to prove it. I can do that here, and there you can see this is set for 2, and these are the same array. It's pointing at the same, a different name, same array. If I instead wanted to make changes that wouldn't affect the original, what I can do is I'll create another array here and call it 3. Well, I can go and copy from our first array again, just by labeling this as a view. And now what I can do is come in, and let's say that I wanted to flatten it. Well, I can go, something really extreme. Well, I could do that. And there you see, I did flatten it. However, if I come in and even though I copied it from this first array, if I come in and print this, you're going to see that nothing changed with it. And if you really want to copy from an array and create a brand new array, you can just go CP. Well, you don't need to do that, obviously. But let's just create a new array here. And to copy and create a new array, you just end this with copy. And there you go. All right, so a whole bunch of different ways you can copy arrays and work with them, and just some information to know about what happens behind the scenes whenever you do so. And now I want to show you a whole host of the basic math functions that are available to you and things you can do math-wise, and then I'll get into specific things like linear algebra and statistics. All right, so I'm going to create two arrays here to work with. So 1, 2, and 3, and 4. And then let's go and create another one after that. Let's change this to 4. And to differentiate them, let's have everything in here be a even value, right like that. Well, I can come in and add these together. So we can go array 3 plus array 4. You can see our answers. We're also going to be able to subtract them. We're also going to be able to multiply them. We're also going to be able to divide them. And you can see all those changes. Let's go and create another random value inside of here, or a random array, I mean. Call that array 5. Going to call random again. Let's get a random integer and up to 100. So that would be 0 up to, but not including 100. And let's go and define the size to be equal to 2 by 3. I can come in and show you what this looks like. There you are. There's our random array. Actually, why don't I make this be 6, and let's go and generate another one and have it be array 5, and it's just going to be a one-dimensional array. And let's give this a total size of 4. And if you just want to see what that is, obviously it's random, so it's going to change every single time. You're also going to be able to create random floating point values, or random floating point arrays, that is. So let's just go rand like that. Let's say I want to create 4 of them. There's the 4. And I could also go and get a random value from an array just by going random and choice, and then the array you want to pull a value from. So let's say I wanted to get it from 3. Well, it just grabbed 4 for me. Okay, and each time I do it, it should, yeah, see, it's different. You're also going to be able to sum values inside of arrays. So let's say that I have array 3, and I want to sum up everything inside of it. Can do so. I could also come in and sum columns. So let's go and print out array 6 so you can see what it looks like. And then I can go and get array 6 and sum the columns for it by passing in axes is equal to 0. Well, I forgot to put the sum part in there. There we are. And there you can see how that works out. We would also be able to do a cumulative sum of rows by just changing this to cumulative sum. And let's use axis 1 in this situation. And that's how those work. We would be able to get the minimum of each row. And to do the rows, you would do axis 0. Or no, to get the rows, you would use axis 1, that is. So there's that. And then if you wanted to get the columns, well, you could use min. Why don't I show you how to use max instead? And then you can go and play with it yourself and see that this is going to work. And there those go. I want to print out the arrays again, just so you can see them. So array 3 and array 4. There they go. You can also add individual numbers to arrays just by calling add and the array that you want to work with. So let's say I wanted array 3 and I wanted to add 5. There's what would happen if I did that to each of those values. We're also going to be able to add arrays together in much the same way. So just change this to array 4, for example. And that's what happens if you add them together. There's also subtract. So we'll just change this to subtract. And we're also going to be able to multiply and divide. So multiply and divide. And there we are. Let's do some other cool stuff. Let's create a couple more multi-dimensional arrays. Let's redefine array 5. So let's get rid of this part right here. And instead, go NP array. And we'll have it be 1 and 2 and 3 and 4. And then do the same thing, or a similar thing anyway, with our array 6. Just change this to 2 and 4 and 6 and 9. So let's say we wanted to divide the elements in the first array by the second array. And let's go and get a remainder from doing that. Just go array 6 and array 5. And there you are. I mean, there's never any supply of things you can do. Let's say we wanted to return values in the first array to powers defined in the second array. I mean, it never ends. So we'll say power array 6, array 5. There you can see, getting big. We could also do square roots. So let's say we want to get square root of everything inside of array 3. Like that, like that. We could also get cube root. So just change that to CB. There we are. We can get absolute values. So let's change this to absolute. And then we'll throw inside of here 2 negative values and 2. There we are. We can get a exponential of all elements inside of an array just by going exp. And which array do I want to do this with? Let's say that I'll just use array 3 again. There you go. You can see all those different arrays and what they did. Of course, there's numerous different log functions. So have our regular log. We have log 2. Whoops. There we are. And log to the power of 10. And so forth and so on. Another thing that's very useful is you can get the greatest common divisor just by passing in an array of values. So let's get rid of that. And to do so, you just go greatest common divisor and reduce, and 9 and 12 and 15. You can get the lowest common multiple as well. Well, let's run this. There you are, it's 3. And the lowest common multiple is just LCM. Run it. You can see that comes out to 180. You can round up, you can round down, you can round all around. And so let's go and get to round down. You call floor. And of course, you have to pass inside of this floats. So let's pass in 1.2 and let's pass in 2.5. And you're also going to be able to get the ceiling or round up, however you want to call it. There that is. Another thing you can do is, let's say you wanted to generate 6 values and square them. Let's just call this the square array. Just go a range, define your range you want to work with, and 6, and then to the power of 2. And then let's say we wanted to get this done with the third, or array 3. There you are, and that works. So really good stuff. Let's do a couple more here. Let's generate one more array. Let's go call it array 7. And let's have it be a 5x3 array. So we're going to use values from 0 up to 99, except I want them to be 5x3. And let's go and print this out. There it is. Now what I want to do here is I want to go and get the index for the max value per column. So let's call this MC index, and that would be array 7 and argmax, and that would be axis 0. And we can do MC index, and you can see it got that max value. And then we could also go and call to get the numbers that correspond to those indices. So let's do max nums like this is going to be equal to, and array 7, and then the indices, and max nums, and there we are. So there's a whole bunch of different math functions that are built directly inside of NumPy. And before I continue covering even more, I want to show you how to read information from files. All right, so I'm actually going to show you multiple different ways. I'm going to show you a different library called Pandas, which you're going to see more of later on. So we have Pandas, and I'll import this. And it's going to be very useful anytime you need to manipulate tabular data, and it has a whole bunch of other different things. Okay, so, and I'm also going to go and get from NumPy and show you the NumPy way of reading files. Gen from text. Whoops, make sure you spell that right. Gen from text. Okay, so first off, you're going to be pulling information from this guy right here. It's ice cream sales. It's a comma-separated value list, and that's what it looks like, okay? And then I'm going to show you how to create them as well and read from them and just about do everything. Okay, so let's say you wanted to read the table data from the comma-separated value file that I just showed you, and you want to convert it into a NumPy array. How would you do that? It sounds so confusing. No, it isn't. So this is going to represent ice cream sales. I'm going to use pandas here, and CSV, and then you just pass in what you want to read from. So it's called ice cream sales, and comma-separated values. And then what you want to do is go and convert it into a NumPy array to NumPy. And then we can just go ice cream sales. Whoops, got an error because I didn't put an underscore there. There you are. So you can see that it imported all that information into a NumPy array that we can work with. And we will work with it a lot. And now let me show you how to read data using NumPy. So I'm going to call this ice cream sales, and I'll show you how this differs in the next part of this specific tutorial. So you go generate from text and ice cream sales and comma-separated value, just like you did before. And then you just define the delimiter, how that information is going to be divided up. And if you want to go and get rid of nan values inside of here, we can go ice cream sales 2 is equal to, and row, and the nan values are going to be the part where it says temperature and sales at the top of the comma-separated value list. So we say NP, and we'll say is nan row, and cycle through all of these rows inside of our ice cream sales, and then we can say ice cream sales 2, and there you can see that we have those as well. So they're all divided up into separate arrays. Okay, so that is how we were able to pull in information from multiple different files. I'll show you how they differ here as we continue. And up next, I want to talk about some statistics functions. Let's pass on linear algebra yet. That's going to be one of the biggest parts of this whole tutorial because there's so many things you can do with linear algebra. So don't let me forget to cover it. Okay, so let's go and create an array. I'm going to call it S array 1 is equal to NP and range 1, 6. And you can go and see what I did right there. Okay, just generated values from 1 up to but not including 6. And let's say that I want to get the mean. That's easy. You just type in mean. And then you pass in your array you have right here. And there's your mean value. You're also going to be able to get your median value. There it is also. You can also go and get your average value. Oops, don't want this here. And you're going to be able to calculate standard deviations. Let's go and do standard deviation. And with this guy, what I'm going to do is change this up a little bit, throw an array inside of here. Let's maybe change this to 4, 6, 3, 5, and 2. And if you watch my statistics tutorial, you know what standard deviation is. Also going to be able to get variance. Let's use the same ones. There we are. Another thing is you're going to be able to, there's different versions. There is nan median and nan mean. And all they do is if they come across the nan value, they just ignore it. So nan standard deviation and nan variance. That's what all those stand for. Do exactly the same things, and just ignore nans. And let's go and let's print out our ice cream sales. So I'm going to say print ice cream sales. Okay, so there's our ice cream sales, and we're using the ones we got from pandas, if you're wondering. Let's say I'd like to get the 50 percentile of that data. I can go and get it. And in some situations, I'm going to cover exactly like the math a lot, and sometimes I'm not. Whenever I get into the linear algebra, I'm actually going to get a lot into the math and explaining what the functions actually do. Whenever we're dealing with statistics, though, I'm not going to do so. You can see 62.5, 394, and you can get that for any of the percentiles. So if you really like math, you will be very excited when I get to linear algebra, because I'm going to be going and explaining literally what every function does piece by piece. Let's say we want to also get the first column, and just this, like this, and there it is, our first column of data. And of course, you can go and get the second, and there that is as well. Another thing, let's do something a little bit more complicated. Something that's called the correlation coefficient. And what that is it's a measure of correlation between data. So what I want to do is I want to correlate this ice cream sales data here. This represents the temperature, and this is the number of sales per month. And in my statistics tutorial, I did a lot of analysis to see if changes in temperatures increased or decreased ice cream sales. Okay, so that's what that's about. This is temperature, average temperature. This is the number of sales in a month. So if I wanted to figure out if those two things are correlated or if they move in the same direction, that's what it means. Meaning when one goes up, the other goes up. I just go correlation coefficient, and I just throw in IC sales like that. And then I can go 0 and go and get the other array. Throw that in there, change this to 1, run it. And in the situations in which you get to 1 or get very close to 1, that means they're highly correlated. So that means as temperatures increase, yes, more people buy ice cream. As temperatures decrease, yes, less people buy ice cream. And as an added benefit, I'm going to show you how to go and calculate a regression line. Okay, so this is how you calculate a regression line. You get each value of x, you subtract from it the mean, and then you do that. As you do that, you do the same thing for the y. You subtract the mean of y. You sum these products up, and then you divide by the sum of all the x's minus mean squared. Okay? If you want to know this in super detail, watch my statistics tutorial. But otherwise, I'm going to show you exactly how we would calculate a regression line using all the stuff you just saw. So let's say I want temperature mean. I can go and get it. So I'm going to say mean. And I'm going to get my ice cream sales and comma 0. So that's going to give me my temperature mean. Now what I want to do is get my sales mean, and that is temperature mean would be x bar and sales mean is y bar. That's what those things are. And I just need to change this to 1. Now what I want to do is go and get my numerator, and this is sort of a little bit of an explanation of how extremely easy it is to create formulas using NumPy. So I'm going to go and sum these. You can see this is the formula that I am recreating in NumPy. So I'm going to go NumPy sum, and I'm going to say IC sales, and it's going to cycle through all of the x values, and I'm going to subtract from that the temperature mean, and then outside of here I'm going to multiply times the same guy right here. Well, not the same one. I'm going to throw that there. I'm going to change this. This is going to be the information on temperature, or on sales, I mean. Sorry about that. So this is going to be not temp mean, but sales mean. All right, so that's my numerator. And my denominator is going to be the sum of, and I'm going to call square, IC sales, O, this guy right here, to my temperature mean, right there. So just paste that inside of there. There we are. Then I can calculate my slope. This is a regression line, and it's a linear equation. So if you know how those work, I'm guessing you probably do. If you're watching a tutorial about a mathematics library, you probably are well aware of what a linear equation is. So let's go numerator. And if you're not, tell me, because that would be interesting. I would look positively upon that. All right, so we'll say we want to calculate the y-intercept. That's going to be the sales mean minus the slope times the temperature mean. And we can go, if we want to see what the y-intercept is, there that is, as long as I didn't make a calculation error, which I didn't. That's 35.56. And then we can go and get this regression line array just by saying IC sales colon, whoops, 0, whoops. This is a colon, not a semicolon, times the slope. And you can do this on all the values. It's so useful. Like that. Whoops. And then I need to actually show you the regression array like that. And what I do wrong here. Oh, y is not defined. That's because it's supposed to be y underscore I like that. And you can see it went and generated that regression line. So just tons and tons and tons of awesome things. Whenever I start getting into the plot libraries and stuff, they're going to be more example based with pretty pictures everywhere. But I wanted to stay 100% focused on what NumPy does really awesome in this tutorial. And up next, what I want to talk about is trig functions. Okay, so what we're going to do here is I'm going to start off by generating an array that is going to be floats. And what I want it to be is negative pi to positive pi. And I'm going to do a plot here just so you can see what they look like. Okay, so there's that array. And now what I want to do is I want to plot this data out. So I'm going to say plot, and here is our array. And I'm going to show you plots using different trig functions. Let's start off with sine. So pass in our array and run it, and you can see it plotted that out. So pretty neat. Let's do the same thing with cosine. And there it is. And let's do the same thing with tangents. Okay, and there that is. And so pretty neat looking stuff. And you're going to be able to change the axes and things like that, but I'll get into that in a separate tutorial. Another thing we can do is we can get the arc sine, which is going to provide, of course, the inverse. So the arc sine is the inverse of the cosine. So what I'm saying is if you have y equals cosine of x like that, then x is going to be equal to the arc cosine of y. All right, just wanted to cover that. And of course, those are just going to be arc sine. Whoops, make sure you put arc sine. And I don't know, just throw a 1 inside of there. You're also going to be able to do arc cosine, and you're going to be able to do arc tangent. And there is a ton of other ones. For example, here's an additional list of some other functions you can play with. They work in exactly the same way. And you probably want to know how to convert from radians to degrees. You just go rad to degrees, and let's go and get pi inside of there. And you can see that works out to 180. And then likewise, you're going to be able to go from degrees to radians. And let's change this into 180. And you can see you got pi that way. And then as a final example, I'll show you how to get the hypotenuse. If you know the width and height of a triangle, let's just make it 10 and 10 just for the heck of it. And there we are. And of course, this is the formula for generating hypotenuse. Okay, so there we go. And now we're going to get into a ton of examples as we talk about linear algebra functions. Okay, so now I'm going to get into the biggest part of this tutorial, which is going to be all the linear algebra functions. And I'm going to be covering a lot about linear algebra in general. I'll be making a linear algebra tutorial very soon to show you the power that it impedes or gives or provides to you. We're going to need to get our linear algebra module. I'll just put as, and I'm just going to label it as LA. And we're going to be using these two, well, we'll go and use 3 different arrays. First thing I'm going to cover, however, is how matrix multiplication works. And I think you can see how everything lines up here with these different calculations using the dot product. And if you come down, you're going to see the arrays that we're going to be working with. So real easy to remember. We're going to have 1, 2, 3, and 4, and then 2, 4, 6, and 9. And to go and actually create this matrix multiplication with the dot product, all we're going to do is go NP and dot and pass in your 2 arrays that you're working with. So I'm going to have array 5 and array 6. And if we execute that, you can see that we are able to perform those calculations. It's probably best. I'm going to have a link to GitHub with all this stuff in it in the description. You can take a look at everything there. If we want to be able to perform the inner product, you can see exactly how that calculation is made. Well, one other thing is you can actually perform the dot product using more than one array. So I'm going to go LA, and it's called multi-dot. And then you can just go and pass in as many arrays as you'd like. So array 5 and array 6 and array 7, or array 8, I mean. And you can see that that worked as well down here. To perform the inner product, we're going to say NP inner and array 5 and array 6. And there is the calculation for that as well. You're going to be able to calculate the tensor dot product. I'm going to go and create another array here. This is going to be called array 9. And like I said, if you want me to explain exactly how these different formulas can be very useful, make sure you select or click on the notification bell, because YouTube has not been very good about informing my subscribers about my new videos that come out. And I'll go 3 and 4, and break these into different arrays here. 5 and 6, 7 and 8. And if you want to see what this looks like, there's array 9, and that's how array 9 is going to be structured. And then I'm going to go and create array 10 as well. NP array 1 and 2, 3 and 4, and I'm going to define the data type for this to be object. And now to go and calculate tensor dot, pass in those two arrays, and you can see the calculation that was made down there. And of course, this is the calculation up here for exactly how this is all processed. Einstein's summation is going to provide, as it says there, many different ways to perform many different operations on multiple different arrays. And what I'm going to do is I'm going to create some more arrays. Why not? So NP array, and let's just keep this simple, 0 and 1. Go and create another array. Call this array 12. And this is going to be a little bit more complicated. 0, 1, 2, and 3. And 4, 5, 6, and 7. Now basically, I'm going to go and actually show you one of these. So we'll go NP Einstein summation, and then you have to use sort of characters in specific ways, which I'll explain to you exactly how they're structured to go and actually perform numerous different calculations. This is a function that can do a whole lot. So array 11 and array 12. Now basically, this guy right here, what you see, I'm going to put it outside of here so that you can see it and I can explain it piece by piece. Now basically, the part that is on the left side of our arrow, what this is saying is that we are going to be using one axis, that's what that is, for array 11, and two axes for array 12. And then after that, what we are saying we want is a one-dimensional array. And what IJ means is that we want to multiply array 11 and its individual single items by each column of array 12. And then you're going to sum those values. And whenever you do that, what you're going to get is 0. And then you're going to have 4 plus 5 plus 6 plus 7 as your answer. If we go and make this calculation, you can see that's exactly what we got here as our answer. Now there are so many more, and I'm going to show you a whole bunch more. Let's say that you would want to come in and sum all the values in array 11. What would you do? Well, I'm just going to go and do everything inside of here. So I'm going to go, we're going to be using that single axis, and I can go and get rid of this part right here and just pass in array 11, run it, and as you can see, that is going to give us our sum of 1. Because there's only one value inside of there, okay? You're also going to be able to go and perform the dot product. Let's go and actually print these arrays out again. So I'm going to go and grab this. I'm going to use array 3 and 4, and I want to show you what they look like. Let's get rid of that. That can cause confusion. So there's array 5 and 6, and you can see them down here. 1, 2, 3, 4, 2, 4, 6, and 9. Oh, whoops. I went and did the wrong ones. Let's throw in 3 and 4. So 3 and 3 and 4 and 4. Okay, so it's just 1, 2, 3, 4 and 2, 4, 6, and 8. Okay, so those even values. Now if I want to calculate the dot product on those two, again, we're just going to have I here and one axis again. And then we pass in array 3 and 4, execute, and you're going to see that you get our dot product here. Whoops, I went and made an error. Sorry about that. I meant to have an I inside of here. Execute, and you can see that we got our value of 60. And you can refer above to our dot product and exactly how that works up here. Kind of a whole bunch of things I'm trying to teach here all at one time. You can also perform matrix multiplication. Let's use array 5 and 6. So array 5 and 6. And again, you're just going to type in I and j, and then j and k, because we're working with multi-dimensional arrays here. Got a value of 114, and you can see those two arrays that we're working with there and refer to above where I talk about multiplication. We're also going to be able to get a diagonal, and to do that, just change this to II, and let's just do it for array 5. And if we come down inside of here, you can see we got a value of 5 for array 5 for the diagonal that's right there. We're also going to be able to easily transpose these, so let's just flip this to j and I for array 5, and you can see we transpose those values from here to here, meaning moving the row down into the column and then this row up here into the other column. Now there's a whole bunch of other things you could do, but I'm just covering the best of what I use all the time here. You're also going to be able to raise a matrix to the power of some value. How we're going to do that, again, I'm going to use LA and matrix power, pass in our array. I'm going to use array 5, and let's raise it to the power of 2. And you can see it did that for us. And you can see exactly how those calculations are being made right here. Doing my best to move quickly, but at the same time provide information here so you can look this up. I'm just hoping this was going to work out as a really good cheat sheet. You're also going to be able to calculate the Kronecker product of two arrays, and you can see the formula involved in doing exactly that. Just type in Kron and array 5 and array 6. There we are. There's all those calculations for us. You're also going to be able to compute eigenvalues, which once again I'll get into in more detail in my linear algebra tutorial. So array 5, and you can see our calculations down there and exactly what they're used for. There's also another version. This version is going to return eigenvectors, and if you do not need them, you can just type in eigenvals like that, and then you won't get them, okay? And what else? Let's also go and get the vector norm, which is just a square root of the sum of all the values to the power of 2. Very easy, just type in norm, pass in array 5, and you can see that calculation as well. You're also going to be able to get the multiplicative inverse of a matrix just by going LA and inverse, and let's go and get the inverse of array 5. And you can see how that works out for us. We can get a condition number of the matrix. Again, I'm going to get into what all of these do in more detail later. This is basically just for people that already understand linear algebra, and you will understand linear algebra much better later on. We're going to be talking about determinants a lot because they're very useful. You can do things like compute volume, area. You can use them to solve systems of equations, which I'm going to show you here in a second. And like it says here, for a matrix to have an inverse, its determinant must not equal 0. And you can see exactly how we calculate the determinant. Let's go and create array 12 here first. NP array and multi-dimensional array here. And 3 and 4. And to get our determinant, we'll go LA dot determinant for array 12. And what this works out to be is, this would just be like 1 times 4 minus 2 times 3. And that'll be equal to -2. And you can see if we do this calculation, that's exactly what we get down here. You can also get the determinant of a 3 by 3 matrix. So what I'm going to do is go and get array 12 inverse is equal to LA inverse for array 12. and get array 12 like this. You can see how that works out. And then we can come in and say, get our dot product for array 12 and array 12 inverse. And there it works out. Okay. And finally, what I want to do here with linear algebra is show you how you can solve systems of linear equations. Now, I'm guessing you know how to solve linear equations. So, for example, if you had 3x plus 5 is equal to 9x, what we're going to do is solve for x in that situation, which you can see that we did right here. And if you have x plus 4y is equal to 10, and 6x plus 18y is equal to 42, what we want to do is isolate our x, which is going to give us a value of x is equal to 10 minus 4y. Transpose the new value of x inside of our equation and multiply through until we get a value for y, which is going to be equal to 3. And that's how we're able to solve both to find the final value of x and the final value of y. Well, it's very easy inside of NumPy to do exactly the same thing. So I'm going to create an array. This will be array 13, and if I want to solve this exact problem in NumPy, I'll go and put in the 1 and the 4. So this is actually what we're working with. The 1 is going to be the value of x here, and the 4 is going to be that value right there. And then what we are going to do next is handle the other equation that we have. And that's going to work out to be 6 and 18. Well, the 6 comes from here, and the 18 comes from right there. Now what we can do is we'll create another array with our answer. So NP array, and put in our answer. And what is our answer? Well, it's going to be 10. So we can just literally copy it from there, paste it inside of here, and 42, which is right there. So we'll just paste it inside. Whoops, missed it. All right, 42. There we got it. Okay, so we provided both of those equations, and it's going to solve it for us. So we just have to say LA and solve, pass in array 13, and pass in array 14. And if we do, you can see -2 and 3. Exactly the answer we were expecting, -2 and 3. All right. And finally, what I want to do here is return an identity matrix with a defined number of rows and columns. And to do that, you just say NP and I and 2 and 2. And we can also define the data type, which is going to be an integer. And you can see this is an identity matrix where we have diagonally 1s and everything else is 0. All right, so there is a rough overview of a lot you can do in regards to linear algebra inside of NumPy. And up next, I'm going to show you how to save and load NumPy objects. Okay, so let's come in here and array 15 and array. And this is going to be a multi-dimensional array. So let's make it 1, 2, and 3, and 4, just to keep it nice and simple. Now, if you would like to save this, you just say NP save, and then type in whatever you want its name to be here. So I'm going to call this rand array. And then you type in what array you want to save. If you want to load that saved data, then I'm going to create a new array here. And you just go NP and load. But you have to put in the full name. So it's going to be rand array dot NumPy, like that. And we can go array 16, and you can see that it was able to go and get that back. You're also going to be able to save as a comma-separated value file. To do that, say NP save text, and I'm going to call this rand CSV, and it is a comma-separated value file. And what do I want to save? I want to save array 15. If you then want to reload that, you just say NP and load text and pass in rand CSV, and we can go and verify that worked. Whoops, what did I do wrong? Oh, I forgot to put the CSV at the end here, very important. And there you can see it was able to go and get it back again. All right, so cool stuff. And now what I need to do is I am going to show you some financial functions, but I need to go and load in the financial library. So I'm going to show you how to do that. Okay, so whenever you start up Anaconda, what you're going to do, you're going to see a terminal window or a command prompt if you're in Windows that also opens. Well, inside of there, you can use that to load different modules and libraries and a whole bunch of other different things. All you need to do is first make sure pip's installed. So type in conda install pip, and it's going to go and do all this stuff. And it might ask you if you want to proceed. Just click on Y and it will. And then to install the NumPy financial libraries, you're just going to type in pip install NumPy dash, not underscore, dash financial, and it will go and load all those in for you. And that is also how you would load any other libraries that are unavailable. So cool stuff to know. All right, so now that we loaded those, let's go and use them. So I'm going to say import NumPy, and this is an underscore, financial. And I'm going to load it as NPF. And I'm going to show you a couple. There's a couple more that I'm not going to get into, but this should be a good introduction. So let's say that I would like to compute the future value of a $400 investment every single month with an annual rate of return of 8% and see how much money I would have after 10 years. So future value. And I said that I expect to get 8% after 12 months, that's what that stands for. And I want to get the calculation after 10 years, so that's going to be 1012. And I am going to invest $400 every month. So I'm going to say, well, 400 initial investment, 400 monthly investment. And you can see that that's how much money I would have. All right, so pretty cool stuff. You can do this really, really easy and do some neat things. All right, let's do something else. Let's calculate the interest portion of a payment. Basically, what I want to structure here is that I am getting a loan from a bank and I want to output a table of information. So I'm going to get a loan of $3,000 and they are loaning the money to me at 9.25% per year, but that's going to be compounded monthly. And I want to basically chart out that this is going to be 1 year period that I want to pay this $3,000 back. So what I'm going to do here first is I'm going to define my period and NP, a range, and 1 times 12, but this is 0 indexed, so I'm going to go +1. All right. Then I'm going to define my principal. So how much money am I going to be taking from the bank? Well, $3,000. Whoops. There we are, $3,000. And if I want to calculate the amount of money that goes to interest, I can go in and go NPF and interest payments. And the interest payment is going to be 0.0925%. And 12 for the entire year. I will pass in my period. I'll pass in 1 times 12 and the principal amount. All right, so that handles the interest amount. And now I want to calculate what the actual full payment will be. So, and to do, this is going to be the principal payment. The payment on the, not on the interest, but on the $3,000. So, NPF. And payment, and again 0.0925, and this is going to be 12 for 12 months in a year, and period, and 1 times 12, and the principal amount, which is $3,000. Now what I can do is actually generate a table for this. So I'm going to say for payment in period, and I'm going to go index is equal to the payment, which is just going to be numbers 1 through 12. That's all payment it's going to output. So I'll say -1, and I will get the principal is going to be the principal plus the principal payment, and throw index inside of there. And then I can output everything as a chart. So I'm going to say print, and I'll have the payment number show up on there. And I'm also going to, let's go and use NP and round. There's actually a couple different ways to round. And you say to yourself, of course there is. All right, so we'll go and get our payment here. I'm going to round this to 2 decimal places. So index, and then I'm going to say 2 decimal places. And let's also go and round again. And this is going to be the interest amount, IPMT, and index, and 2. And let's go and finally say MP round and output our principal. And again, this time 2 decimal places. And don't forget to close this off with some quotes. Make sure I have them there. I do. And everything else there looks good. Let's check it. And there you can see I went and created a nice little chart explaining the payment back of the $3,000 loan. All right, so it just never ends. There's just always something new to do here. So what else can we calculate? Let's say I would like to calculate the number of payments to pay off $3,000. If I decide that I can pay $150 per month with an interest rate of, again, I'll just keep this the same. I'll put it at 9.25. Well, I'm going to round this. So I'm going to say NP round, NPF, and NPER. So I don't know the number of payments. I'm just putting down my terms. 0925 and paying every month. And I'm going to pay $150, and $3,000 is the initial amount. And I'm going to round this to 2 decimal places. And if I do that, you can see it comes out to 21.8. And why not do one more here? So let's say that I want to calculate the net present value of cash flows in the future. I expect to get $4,000, $5,000, $6,000, and $7,000 after an initial $15,000 investment at an 8% interest rate. Okay, getting a little bit into the weeds here, but thought this would be kind of interesting just to show you all the different little hidden secrets we got here. Okay, so we have an initial investment, so we're getting $15,000 at 8%. We went and took a loan of $15,000, and then we expect to earn $4,000, $5,000, $6,000, and $7,000 from that loan. What is the net present value? And you can see it comes out to $2,898. All right, some neat stuff. And to finish off the tutorial here, I just want to show you some different comparison functions that are available to us. And then you can go and experiment with all the stuff you learned about NumPy. All right, so let's come in and let's create another array. And I'm going to call this MP array and throw 2 and 3 inside of there. And let's go and create another one. Let's call this array 2, and let's throw 3 and 2 inside of here. So 3 and 2. And what we can do is we can come in here. This is what these different functions are going to do for us, is they are going to return different booleans based off of whether array 1 values are greater than, less than or equal to, and so forth, versus array 2 values. So I'm going to go MP greater and throw in our first array and our second array. And you can see it comes back as false and true. And you're also going to be able to do greater than or equal. So there's that. You can see that comes back as false and true also. You're also going to be able to do less than in comparison between those different values. See, that comes back as true and false. We're going to be able to do less than equal. True and false. You're also going to be able to check for non-equality, so not equal, and you can also check for equal. All right, so there you go. I did my best to give you a pretty thorough coverage of all the different things you can do with NumPy, and as I continue, I'm going to cover all the different frameworks and libraries that are going to work with NumPy to enhance and improve upon it. So like always, please leave your questions and comments down below. Otherwise, till next time.